Hey scientists, it's Jessica Power from Kansas State Public Schools, one of the science curriculum coordinators. Scientists, we are so close to Halloween, so I thought maybe we could take a break from talking about the things that we're currently learning in school, and we could do some science that is impacted with Halloween. So let me start with a story about me when I was a little girl. So every Halloween when we go trick-or-treating, my parents would always get me a glow stick. And then have me put that glow stick into my trick-or-treat container. That way I could be visible, right? Because it's dark outside. Well, scientists, when we would get home from trick-or-treating, my parents would take that glow stick and they'd put it in the freezer. And I always thought it was the weirdest thing because I liked the glow sticks. I wanted to have the glow stick with me. But they would put it in the freezer. Well, it wasn't until I was older that I learned why. And so scientists, today we're going to talk about why my parents used to put my glow sticks in the freezer. So you'll notice that in front of me today, I have 3 glasses. One is filled with ice. One is actually just room temperature water, so it's the same as the room. And then this other glass is currently empty. What I'm going to do is in this mug, I have just heated up this water, and you may be able to see that there's steam coming off of it, maybe not. This is really, really hot. Like, burn your mouth, burn your throat, burn your hands if it spills on you. So I'm just gonna carefully pour this hot water in this glass and put it down quickly so it doesn't burn my hand. And then next, scientist, I have 3 glow sticks. So what we are going to do today is we are going to determine how does temperature affect a glow stick. So let's talk a little bit about glow sticks. Whew, that's hot. Glow sticks are nothing more than a chemical reaction. So if you've ever looked inside of a glow stick very, very carefully, you may notice that there's a tube within this tube. So you'll see that there's this kind of colored liquid on the outside. And inside is a glass tube that's filled with another liquid. Now, when these 2 liquids combine, they cause a chemical reaction, which means that we take one substance, we combine it with another substance, and it creates a brand new substance. If you've ever seen baking soda and vinegar mixed together, you have a white powder and a liquid, and they bubble, that's also an example of a chemical reaction. Well, one piece of evidence of a chemical reaction is that light is produced. So that means that light forms. So in order to get a glow stick to occur, the chemical reaction, we crack the glow stick, the glass, and then we shake it up. So I'm going to do that with all 3 glow sticks. Just 2 and 3. All right, so we have our glow sticks. Trying to get it all lit up. Now, we have 3 kinds of water: ice cold, room temperature, and very, very hot. Now, scientists, what's happening with these glow sticks is there's energy, right? Okay, so we are seeing light energy come out of this chemical reaction. During chemical reactions, energy is key. So what we're gonna what we're gonna see is we're gonna make observations of the effects that the 3 temperatures have on the glow sticks. So you can see these 3 glow sticks. They're all bright and they're all shining, if you will, the same type of brightness. I am going to place the first glow stick in room temperature water. Now, you may be wondering, why do we have room temperature water? Why don't we just have really, really cold and really, really hot? And scientists, to answer your question, every really good science experiment, any valid or right science experiment, has something called a control. And a control is something that stays the same. So right now, by putting the glow stick into the room temperature water, right, the temperature of the air around me, I am creating a constant. So that means that whatever happens in the hot water and whatever happens in the cold water, we can compare that to our constant to see how the effects of the temperature are happening. Second thing I'm gonna do is I'm gonna drop this glow stick into the really, really hot water. And the third thing I'm gonna do is drop this glow stick into the really cold water. And scientists, I'm gonna give this a second. And hopefully you're starting to see something happen. I'm gonna wait for a second. I already see something happening. Do you? So scientists, you may notice that our glow sticks are actually shining or producing a different amount of light. So you'll notice that the regular glow stick, right, the glow stick that we just put into the constant, the room temperature water, it hasn't really changed in its brightness of how it's glowing. It's constant. That means it's staying the same. Now let's do a really quick compare and contrast. If we compare the glow stick in the constant or the control, and we compare it to the glow stick that's in the really, really hot water, what do you notice? Which glow stick is glowing brightest? Yeah, the glow stick that's in the hot water. And you can see, grab them up here, you can see that clear difference. The glow stick that's in the hot water is glowing much brighter than the glow stick that's in the room temperature water. Now let's compare the glow stick in the room temperature water to the glow stick in the ice cold water. Do you see a difference? Which glow stick is brighter? If you set the glow stick in the room temperature water, that's right. So scientists, what we have here are 3 different glow sticks that are going through their chemical reactions at different speeds. I want you to think about wintertime and think about when it's really cold outside and you're really cold. It's a little bit harder to move when you're really cold, right? You just feel a little bit more stiff. Well, scientists, when our glow stick is in the ice water, it's actually causing the chemical reaction to slow down. Now, the chemical reaction will last as long as the glow stick is glowing. So once this glow stick stops glowing, the chemical reaction is over. So this one is our constant, it will stay the same. And this glow stick may glow for 2 days, we'll say. Now this glow stick, if we keep it in ice cold water or I put it in the freezer, this glow stick will actually glow for about 5 or 6 days. So glowing about 2 days, glowing about 5 or 6 days. Do you think the glow stick in the hot water is going to last as long as the glow stick in the room temperature? It's not. Scientists, this hot water is speeding up the chemical reaction. It's making those 2 liquids react faster. So while this glow stick is glowing the brightest right now, it actually will stop glowing faster than the other 2, simply because the temperature of the water is affecting how fast the chemical reaction occurs. Now we call this type of reaction chemoluminescence. That just means that we're using chemicals to cause illumination or light. So scientists, let's go back to the beginning. And I told you that story about when I was a little girl. And it's a true story, by the way. And I told you that my parents used to put my glow sticks in the freezer. And I was really confused. Well, scientists, now that we've done this test today and we've taken a look at how does the temperature affect a glow stick, why do you think my parents put the glow stick in the freezer? Yeah, if you said my parents put the glow stick in the freezer so that it would last longer, that's correct. Because we talked about, scientists, the longer or the colder the temperature the glow stick is exposed to, the slower that chemical reaction occurs. Now you want to see something kind of cool? Let's take this glow stick out of the cold water and let's actually put the glow stick in the hot water. What do you think is going to happen? Yeah, let's see. If you made a prediction that it's going to start glowing really bright as well, I'll turn that towards so you can see the difference. You'll start to notice that there is a change occurring in that glow stick that was in the cold water. you'll notice that the glow stick is now starting to burn or shine brighter. So the glow stick that was in the cold water is actually the one that's on the left. And you'll notice that it's actually now shining, or the reaction has sped up, so it's glowing as bright as the one that was in the hot water to begin with. Now we can play games with the glow sticks. We can take this glow stick out very carefully so we don't burn our fingers. And we can put it back in the cold water. And scientists, as that glow stick sits in the cold water, you'll notice that it slowly will become more and more dim. So scientists, Halloween, I think about glow sticks. I think about candy and I think about glow sticks. And so this is just a fun way to talk about how science is always around us and science is always impacting us. So if you get a chance to get some glow sticks this year, test them out. You can do this experiment at home. If you have 3 different glow sticks, they don't even have to be the same color. You can have different colored glow sticks. But get some hot water, get some room temperature water, get some ice water, and see how see how fast the glowing becomes bright or how dim the glowing occurs based on the temperature that the water is. And remember, it's all about the chemical reaction. It's either about speeding it up or slowing it down. And you'll see that our glow stick in the ice water is now back to being dim. So scientists, happy Halloween. I'll see you next week.